Hi, my name is Adrian, and I'm a solutions architect at AWS in Singapore. Today, I want to share 12 things I wish I knew when I started with AWS. 12 things I learned the hard way. This is a level 100 talk, so I'll assume that you are fairly new to AWS. Most of the recommendations can be adopted at low cost and are suitable for your personal account at less than $1 a month. There are a few exceptions to this. I'll point these out when I get there. Before I start with my recommendations, I want to set a bit of context. Why are we adopting AWS? Customers are saving a lot of money by moving to the cloud. Research across 1,500 enterprise customers shows a 51% lower cost of operations across 5 years. Staff is 62% more efficient, and operational downtime decreases by 57%. Research shows an 88% reduction in carbon footprint of IT operations. But perhaps the most important advantage of moving to AWS is business agility. Customers report a 37% decrease in time to market. Releasing new features faster is a competitive advantage. At the same time, we need to ensure the governance of our IT. Releasing features fast and ensuring compliance and security should not be a trade-off. You can do both. When you are starting with AWS, you will find over 200 services. It may not always be obvious which one you need. AWS Cloud Operations is a framework that helps customers find out what is needed to build and operate securely and successfully in the cloud. Now, I can hear you think, you are talking about setups as small as $1 a month, and at the same time you're using expensive terms like governance and compliance. How do you reconcile that? Actually, the fundamentals of security, governance, and compliance are low cost. I wish I knew this when I started with AWS. Let me start with the most urgent message of the day. Fortify your root credentials. As a starting point, do not use your root credentials unless you really have to, and that should be exceptional. Instead, use IAM credentials or single sign-on. I'll talk about this later. Why? Root credentials have no boundaries, and you need to set boundaries even for yourself. So how do you protect your root credentials? A password alone is insufficient considering the importance of a root account. You need multi-factor authentication. For the root account, I recommend a hardware token similar to the USB key pictured on this slide. Some of you might use an authenticator app on your smartphone. I suggest that is fine for your IAM credentials. And it can work for your root account, but for your root account, I recommend something more durable. Smartphones have a habit of falling, breaking, getting lost. And even if they don't, the app can get out of sync with the account. A hardware token you can put in a safe deposit box and store for many years, no issues. Or for your personal account, put it in a jewelry box and tell your significant other that this is your most precious piece of jewelry. Then finally, have you ever thought about what happens if you lose your multi-factor authentication token or password? If you lose your root password, you can reset it through a forgot password email. If you lose your multi-factor authentication token, the easiest way to reset it is by requesting a phone call to the number registered with the AWS account. Question: which phone number is registered with your account? Who owns the number? I have been in situations where the number belonged with someone who had left the company. Oh, and the country code was not registered. If you get there, it becomes painful, and you need to follow a process with notarized documents. Please avoid that. Here's my recommendation. On one hand, you have the password and the recovery email address. Put these two under the control of one party in your company. For example, the cloud operations team or the financial admin for your team. On the other hand, you have your multi-factor authentication token and the recovery phone number. Give these to another party, for example, your security team, and have them store it in a safe deposit box. And make sure you include your country code as shown in the screenshot. After you fortify your root credentials, you should further refine your access. When it comes to security, it is good to take a belt and suspenders approach. What do I mean by that? If one mechanism fails, you still have another mechanism to fall back on. When I started with AWS, I had a single AWS account and full admin access across that account. That is only slightly better than using root credentials. Moreover, mixing production and non-production workloads into a single account increases operational risks as well. My recommendation: start with a multi-account strategy. Yes, even for your personal account with less than $1 a month bill. For example, you can use AWS organizations to set up a management account with 2 child accounts, say one for production and one for non-production. That's the minimum. Split up further or much further in a larger company. The advantage of this setup is that you can scope down permissions to strictly and only the services you really need with service control policies. For example, your personal account. Do you ever expect to be running a 48x large instance? Probably not. So just rule out that possibility. Then, in case a malicious actor gets access to your account after all, their blast radius is reduced to the smaller instances. Similarly, remove access to regions that you never plan on using. That is what I mean with belt and suspenders. For professional use, your next step should be AWS Control Tower, which adds control mechanisms. What is the single biggest quality of good sushi? It should be fresh. When it comes to access keys, ask yourself this question: would you eat sushi this old? For access keys with wide permissions, limit your expiry time to 1 hour. For access keys with narrow scope and minimal impact, you may extend their expiry time to a couple of hours. But I think we can all agree that yesterday's sushi is a health hazard, and even more so as it gets older. So how can you achieve this in a practical way with access credentials? Use AWS Single Sign-On. It is the perfect companion for your multi-account structure at no additional charge. With a single set of credentials, users can access multiple accounts. If you need access keys for programmatic use, such as the command line interface, you can get a set of short-living credentials through the same console. This way you never have to worry about old access keys. AWS has a number of very helpful tools to spot security threats in your account. However, if you ignore the alerts from these tools, they'd be absolutely useless. I once visited a customer with severe security alerts that had been open and unnoticed for 5 months before. My key learning is that you need to configure alerts in a way that cannot escape your attention. Amazon Guard Duty is a threat detection service that continuously monitors your AWS accounts and workloads for malicious activity and delivers detailed security findings for visibility and remediation. Make sure that at the very least you configure SNS alerts that send text messages to your phone and emails just in case. Setting up alerts works through Amazon Event Bridge, formerly known as CloudWatch Events. If you are a professional user, then connect it to your ticketing system and your mechanism for operational alerts or escalations. Think of PagerDuty. Amazon Virtual Private Cloud, or VPC, is very flexible and powerful. A common pitfall when starting with VPCs is to over-engineer the network. I love to draw boxes on dry erase boards. So when I designed my first VPC, I drew separate subnets for every workload. As a result, my network reflected application-level architecture. The problem is, subnets are probably the least flexible aspect of my network. Once you set it up, you cannot easily change it. You'll need to delete and recreate it instead. And to do so, you need to migrate all your workloads with it. And the benefit? Practically none whatsoever. Instead, here's a fairly simple and generic VPC design. The public subnet is potentially accessible from the internet. The private subnet can initiate access to the internet, but the internet cannot directly initiate access to resources in the private subnet. The isolated subnet cannot communicate with the internet at all. Quick warning, the services pictured in this slide exceed the $1 a month budget for personal use. So this is just an illustration. Which workload do you put in which subnet? The public subnet. Minimize its usage as much as you can. Most resources do not need the public subnet. What are exceptions? For example, an internet-facing application load balancer or net gateway. Both are AWS managed services, so a lot of the heavy lifting to secure these services is handled for you by AWS. Avoid self-managed EC2 instances in the public subnet as much as you can. In the private subnet is where you typically host your self-managed services. They are not directly accessible from the outside world, but still can connect to the internet, which is a common requirement. Finally, the isolated subnet. Some people call it the database subnet. And sure, databases are a perfect use case for the isolated subnet. But why limit yourself to databases only? You can host any service that doesn't need internet access. Again, belt and suspenders. A few slides back, I said I like to draw boxes around workloads. You still can and should, as long as the boxes are flexible. In this diagram, the boxes indicate security groups. Security groups act as a virtual firewall and are easily adjusted, so use them extensively. For personal use, you'll want to avoid NAT gateways, and then you have to stick with public and isolated subnets only. You might be tempted to use the default VPC, which consists of public subnets. If that is what you want, that is fine. Just make sure you design your security groups carefully. However, if you want to customize something, I recommend creating a new VPC with a similar setup instead. Otherwise, you'll struggle to restore the default VPC to its original state at a later point in time. A standard, unmodified default VPC will sometimes come in handy when troubleshooting, so preserve it unmodified. How do you reach an EC2 instance in a private or isolated subnet from the outside world? In the past, the only way to do so was a bastion host in the public subnet. The name bastion host may sound secure, but is it really? Here's the good news. We don't need the bastion host anymore. There's now something better. AWS offers access to your EC2 instances with AWS Systems Manager Session Manager. This is a service that allows you to set up terminal connections and other network connections from your own laptop or desktop to your EC2 instances. And it is well secured with IAM credentials. When someone connects to an EC2 instance, it leaves an audit trail in AWS CloudTrail. More recently, AWS introduced AWS Systems Manager Fleet Manager. This gives you the possibility to connect with Windows Server UI from your browser. This is particularly useful if you need to manage a system that is not easily accessible through the command line interface. Did you notice that I consistently draw 3 availability zones? Quick reminder, an availability zone, or AZ, consists of one or more discrete data centers, geographically separated from the other availability zones to avoid the risk of physical influences taking down more than one AZ at a time. The great majority of AWS regions have 3 availability zones. Some regions have even more. When I started with AWS, most of my drawings only utilized 2 availability zones. I'd keep the 3rd availability zone as a spare for just in case. This is a bit counterintuitive. It turns out that only 2 availability zones is inefficient. I'll explain why. Warning, the next few examples exceed my $1 a month personal budget, so don't do this at home. For argument's sake, let's start with a single availability zone and no high availability, or HA. Let's say my workload requires 16 vCPUs to handle the customer's traffic. What happens in case an availability zone goes down? Well, if you're lucky and it is AZ B or C, then nothing. If AZ A goes down, then you have a major outage, and that is bad for business. So assuming this workload is business critical, we need HA. The traditional way of doing HA is to have the same workload copied across 2 availability zones. Notice here that my cost doubled. I am paying for 32 vCPUs, while ideally I only need 16. In return, if an AZ goes down, I still have 16 vCPUs remaining. Could we have done that in a smarter way? Let's use all 3 availability zones. Please take note, here I did cut the instance sizes in half. Each instance has 8 vCPUs, adding up to a total of only 24 vCPUs, rather than the 32 in the previous scenario. That is a 25% cost reduction. In this case, if one availability zone goes down, I have 2 availability zones remaining, with a total capacity of 8 plus 8 is 16 vCPUs, which is what I needed. Now, I know, the older workloads may not be architected to scale out this way. But if you are designing a new and modern workload, I strongly recommend using all 3 availability zones in your region. When I first started using AWS, I was totally confused by all the instance types available. And since then, the number of options have increased exponentially. A full talk about instance types could be a separate conference presentation, so let me summarize one important learning. As a rule of thumb, new is better. You'd be surprised how often I see brand new workloads deployed on old hardware. And to be fair, this isn't always obvious when you're doing this for the first time. A word of caution, for your personal account, make sure you either stay within the free tier or run instances only for a couple of hours rather than full time. In many cases, new instance types come at a lower cost than their predecessors. This gives you an incentive to stay up to date with the newest technologies. It is not only about pricing. If you buy a laptop and you're offered a choice between a 2015 model and a 2020 model, which one do you choose? Probably the 2020 model, because new laptops typically give a better performance than the older ones. Now, if the 2015 model is even more expensive than the 2020 model, that should be a no-brainer. In this slide, you see price performance improvements for instance types according to their original announcements. So next time you select an instance type, make sure you get the latest generation. Start with serverless. When I first heard of AWS Lambda, I thought it's a cool and innovative technology, but I did not immediately understand its use case. AWS Lambda allows you to deploy your own code as a function, and you only pay for every millisecond that it runs. I wondered, what use is that? A single function running for 70 or 80 milliseconds? When you have a brick in your hand, it's hard to imagine a building. However, if you design a building, you can see where all the bricks come in, together with all the other pieces. The term serverless covers a much broader spectrum of services than just AWS Lambda. Think of S3, DynamoDB, SQS, SNS, EventBridge, step functions, and many more. The value of AWS Lambda becomes clear when you are using it in combination with other services. For example, you want to perform an action whenever an object is uploaded to S3. With AWS Lambda, that is simple. When files do come in, they get processed instantaneously. And when no files are coming in to S3, you are not paying for compute capacity. A number of years before I worked at AWS, I was an AWS customer, and I was terrified of lock-in. And I was convinced that databases are most prone to lock-in. So far, that is a fair argument. In my quest to avoid lock-in, I architected my project based on the company's standard NoSQL database. This was a self-managed database supported by a vendor. When the go-live date approached, the vendor gave their sizing recommendations. I had sized for 1 node per AZ, which was a substantial portion of my bill of materials. The vendor said, we need 3 nodes in each AZ, so that cost blew up pretty quickly. As a result, I had successfully avoided lock-in with AWS, but instead, I had locked myself in with something much more expensive. What I should have done is architect based on Amazon DynamoDB. DynamoDB is Amazon's NoSQL database, which gives you single-digit millisecond response time at any scale. Not only would it have been much lower cost, it would have been much easier to run in production. All of the heavy lifting of running a NoSQL database is done for you. You can configure DynamoDB with on-demand capacity, which means you pay per request. It also means it is a serverless database. This is perfect for a $1 a month personal account. There is virtually no limit to how far it can scale. With Amazon Prime Day in 2021, DynamoDB handled a peak load of 89.2 million requests per second. Suppose you want to do something seemingly simple, such as hosting a website. In the old days, you might have used a content management system with PHP and MySQL. This seems simple on the surface, but there still are a lot of moving parts and self-managed software to maintain. In more recent years, it became popular to host static websites using open source tools like Jekyll, Hugo, or Gatsby. These tools generate HTML, CSS, and JavaScript that you can store in an S3 bucket and serve as a website to the outside world through Amazon CloudFront, Amazon's content delivery network. That is a simple and scalable architecture pattern. You do need to learn how to configure CloudFront for your use case. The good news, there is an even simpler way. AWS Amplify is a service that simplifies building web and mobile applications. If you want to host a website and you use popular frameworks like Hugo or Gatsby, you just point the AWS Amplify console to your source code repository, and Amplify does the rest. It creates a pipeline, builds your website, it hosts your website under your domain name if you want to. My last recommendation for today: adopt open source software and save cost. Amazon is a customer-obsessed company. 90 to 95% of our roadmaps are driven by customer needs. Open source matters to our customers, and so it matters to us. Amazon is developing, contributing, and innovating in open source to help our customers. Our goal is to ensure that AWS is the best place for our customers to run the latest open source solutions, whether that is directly through AWS services, via partner solutions, or within customer-developed code. How much are you currently paying for your operating systems? Or for running Java? Amazon Linux is Amazon's Linux distro. Amazon BottleRocket is another Linux distribution purpose-built for running containers. Amazon Corretto is Amazon's distribution of the Java development kit. All of these are available at no additional cost. And if you have an AWS Premium support plan, you can file support cases when you need assistance. These are 12 things I wish I knew when I started with AWS. I talked about security basics and account setup. I covered networking design. I talked about simpler ways to host code, databases, and web applications. I encourage you, try these out. If your company gives you a sandbox account, great. If not, get your own account. Follow the security best practices I shared in this presentation. There's so much you can try out and learn for under $1 a month. Oh yeah, and do configure budget alarms for just in case. Thank you for attending my presentation. This was Adrian from AWS. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.